My name is Alessandro. I'm Head of SRE at Synthace. The idea was to present about the tool that we developed at DeepMind Health, my previous company, and some of the team is here tonight as well, which is Kapitan. Is a tool that is being used for managing Kubernetes configuration especially, but also Terraform and other things. The idea was rather than going through a strictly technical presentation, I wanted to show the challenges of starting new in a new company where you find lots of problems are there that you're trying to solve, and how you go about introducing a tool of this kind of impact without disrupting the work of other people. So yeah, myself, I recently joined Synthace from March. I used to work for DeepMind Health before, Google, DeepMind. Some of my old colleagues are here in the audience, so if you hear clapping, it's probably them. And we are basically joined Synthace since just a few months. This is a little bit of my social media. I don't have much traction at the moment. I have almost 100 followers on Twitter, so help me out. We are hiring on Synthace, so have a look at the website. Just a little talk about this. Here we go. No access here. Fair enough. So Synthace is I'm using somebody else's laptop, sorry for that. Synthace is essentially a company that aims to solve automation for biology labs. So the same problem that we might find in the computer industries are actually affecting other industries as well. Biology is one of the places where the presence of like robots and the presence of other technologies to manage the labs hasn't been reached by automation in that sense. So the aim of Synthace is to create like a software that allows biologists to, the very same way we do, to repeat experiments over time and to be able to gather information and going through the process of experimenting new drugs or speeding up cancer research with the same kind of tooling and the same kind of approach that we would have in the IT kind of world. So we're using kind of this tech stack, and I just wanted to show the situation I found myself into, as in we're using all of it. And we're using like DNS from 3 different providers. We're using like cloud services from 3 different providers. We're using Cloud Build, Travis CI, GitLab CI, and it's basically the sign of a company that over time has progressed and has created like different kind of, has pivoted in different kind of areas, has developed software, sometimes not in a structured way, but it gets to a point where you suddenly find the confirmation from the market that your company is solid, so we received a very good investment, but you still have all this kind of legacy work that you've done, and you need to get into a better shape. So I come in on March and confronted with basically this kind of situation. My first work was to sit down with the engineering team, with the VP of engineering, with all the developers, and try to understand, basically taking stock of the situation, trying to understand how I could help them before getting into a solution space where I could just come and bring improvements. I found like a little bit surprised to see some of these kind of statements that they were giving me. I mean, in the previous company, we were using microservices a lot. We were using gRPC, we were using Kubernetes, we were using like cloud services. I mean, DeepMind is owned by Google, so that was the natural kind of inclination to use all the open source tools and managed service provided by Google. But here, I realized that most of the people were actually starting to turn against this technology and go back to other kind of traditional approaches. So today I had a conversation with somebody who asked me whether I would think using like Kafka better than kind of a pub sub was a good idea, which is something that I'm happy to discuss. But my point was that I wanted to understand if these kind of decisions were influenced by the fact, by the lack of tooling, by the lack of automation that would allow, would prevent them to actually enjoy these technologies without the challenges of having it running on their laptop, or having to manage the configuration of Kubernetes, or having to deal with software that they are not always ready for developers, or they are just they're just there for a special category of people, mostly for DevOps, but and for operation people, or at least were thought for them. So this is where I usually start ranting about Kubernetes a little bit. I don't know how many people are using Kubernetes here. I don't know if somebody can raise hands. There's quite a few. So the thing that I found more difficult is when developers are using Kubernetes, they found themselves between kind of a limbo between what's provided as a tutorial online, where everything looks nice, and what's the actual reality when you want to introduce Kubernetes in a real company. So the typical tutorial is, hey, look at this, I can run an application on port 8080. Oh, look at me, I can scale it up, and I can even create a load balancer straight away and having my application connect there. So this is what actually they see. This is how they imagine it is to run a Kubernetes service. The reality is, like, the moment in which you bring this into a real company, you have to deal with it in a different way. You need to deal with it as a declarative, with a declarative approach, where you need to be in control of every single configuration file that Kubernetes needs, and needs a lot of them. So you find them like lost in this multitude of configurations files, and it's not even provided to you this kind of more pleasant kind of interface. Like, for instance, if you use VMware, or if you use even Terraform, there is some sort of a tooling that allows you to make a diff between your state and what's out there, or you have like a UI that allows you to go through this kind of setup. Then I have found other kind of frustration from an operation point of view. So we have 3 environments, and I come from a setup where we used to have like probably 40 environments and be able to spin them up like at will. So we had 3 environments, and we were struggling with it. So first of all, even the friendly names are, I changed the names a little bit just to not make it super obvious, but even the names don't map like what they're actually meant to be doing. And they are on different projects, on different cluster setups. They're using different way of connecting to Kubernetes. Some of them use integrated like CI, some of them they don't, and so on. Basically, each Kubernetes setup was a snowflake. The only thing they had in common is they all of them were out of date, and I had to basically bring them up to speed. So that was at least one thing. Other general frustration is documentation and releasing was very complicated. Kubernetes secrets were kind of used as a way to access secrets to other clusters, and they were not managed in any kind of optimal way. There was like certificate expiring and other kind of issues. The manifests were generating using an approach of using Golang to generate scripts. So basically, it's a Golang code that is basically behaving almost like a bash shell, but because it's Golang, I think it feels more like serious as an approach. And this is like a company where this happens everywhere. When I talked to the VP of engineering, we were like, especially kind of the idea of showing how a company looks like a startup some startup look like, because it just sometimes the approach to address technology like Kubernetes is not clear. There is no strategy or no defined strategy of how you manage your configuration in Kubernetes. There is no solution. There is a Helm, there is like Customize. Kapitan is the one I'm going to try to sell you tonight. But pretty much there is no like a standard approach on how to go about managing a complex configuration of, say, 30 microservices where the configuration is like complex to manage, and you have like different cloud environments, different setup, and you also have to deal with moving forward and making kind of more development. So this is a crash course for Kapitan. Kapitan itself is something that requires a little bit of learning. So you can follow on our blog like tutorials on how to learn about this kind of tool that was developed at DeepMind Health. Essentially, it's basically something that allows you to produce configuration files. We happen to use it for producing configuration files for Kapitan, for Kubernetes, but it's not only meant to be used that way. It's a blend of basically different kind of templating engines, so JSONet, Jinja, and some recently a Python kind of layer onto that. And it allows you to generate anything for Kubernetes, Terraform, or even your internal tool. Some of our customers are using it for connecting to internal tooling where they didn't have support, they didn't want to do it themselves. So we're still being kind of noticed. It's still in the phase where it's picking up. The spike where you see the curve going up is when we started actually writing what we are doing, because until then we were too busy using it that we wouldn't write blogs or do anything about it. But if you look at the Kapitan blog, it will give you like a gentle introduction of all the kind of aspects, all the concerns we are trying to address. We're pleased to have, I couldn't mention some of the companies because they wouldn't allow us to write it publicly, but it's nice to know that companies using it are companies trying to address complex kind of infrastructures. It's not usually the situation for kind of simple setup. So we are in this kind of niche market of people, companies that have a lot to manage and they don't know how to solve that problem. So in essence, this is what Kapitan is doing. There is a concept of an inventory. An inventory is basically where you store all the data about all your deployment, all your data, everything you want to track. The inventory is itself a YAML structure, and we use a concept of kind of an inheritance to allow you to share values across different kind of different environments. Within the inventory, you can define a target, which is what allows you to define what you want to deploy where, and then this inventory goes through of your choice 3 different templating engines, whichever you want to use, whichever suits your kind of your application the most. What you get at the end is basically compiled manifest files, like for Kubernetes in this case. So the top part is Kubernetes manifest. The second part is actually scripts, like this is like bash scripts. But what we do is we kind of using the inventory to inject values into those scripts so that you can remove from your setup that kind of a runtime aspect of having to pass parameters to a script, because the moment in which you pass parameters to scripts, it becomes like it becomes no deterministic if you are having script running, this specific script run by another person of your team. So we use this especially to work around the problem with the Kubernetes context and the fact that kube control relies on that kind of implicit context, which is the one you default to, which makes it very dangerous if you're using Control R and you're putting your kube control to production, and then suddenly all your deployments go in one go. So basically, it's the inventory uses the concept of targets as an entry point, so you can define multiple targets, and a target looks like the one on the right-hand side. So it's basically a way to define classes that share or that contain basically some values which you want to bring in that specific configuration, and allows you to map what normally would be like configurations into something that can be like have some sort of a business kind of related kind of concept. So you can have a concept of releases. You can have a concept of cloud environments you're connecting to, or whether you want to use Minikube or not. You can also use selectively import components that you want to deploy to a specific target. Like in this case, I'm importing, among the others, a component, something called postgres-proxy, which then brings in this other class, another class that basically adds to the stack of the other configuration we have created, and defines other kind of parameters, other fragments of YAML, which at the end will create a more complete view of what that target looks like. So we can see, I just can point to a couple of things. So this is where we define, for instance, images. This is where we define secrets or allow Kapitan to understand that there is a concept of secrets. And this is the link between what is the inventory kind of file and the actual template that will be triggered when the target is compiled. So this is an example of JSONet, which is basically a language developed within Google to define data structures in JSON. This is just fragments, just to give you an idea how it looks like. But basically allows you to code what they will become like YAML files using a language that supports inheritance, it supports like object-oriented approaches, and it makes it easier to sometimes define behavior across a number of different components you might want to deploy. So in case of microservices, if you have like 30 microservices, you will be able to create a generic class that defines that behavior and then inherit from that, or at least use that as a way to generate all the rest of the configuration. So I try to go through that as quickly as possible. Unfortunately, it is a tool that requires you to understand how it works. It solves a complex problem, so it requires you to understand how it works. But what I wanted to talk about is more like how do you get a tool like that into a company that is already running, where first of all, you first arrive, you don't want to create like outages, you don't want to look like the guy who's bringing the tool that they developed in the previous company, and you also want to make sure, get a reassurance that you're doing the right thing, that you can always step back in case something is not working or something doesn't match your company. So my agreement with the VP of engineering was that I would be working for a month doing literally nothing. As in, I would be basically recreating exactly the same manifest that they have, but I will be doing it differently. And I got to the point where I was even kind of mimicking the same mistakes they had in the current manifest. Because what I wanted to do is reach an approach where I could basically prove to them that they could use this new Kapitan tool instead of their current tooling, because the effects were exactly the same. This allows me to basically reduce the feeling of risk of adding a new application, a new kind of process into your company, because the last thing I wanted to do is to create an outage in my first 2 months there. Also wanted to make sure that, because basically I wanted to onboard and get people on board with this kind of approach, I wanted to make sure that if some developer thought that this wasn't a good idea, I had a way to negotiate with them and to train them and to explain them my point of view before I had already locked the company into this new tool. So this was basically my approach. So literally 1 month working on it to replicate exactly what they were doing with their Golang scripts. So what I started doing is basically try to create a structure that mimics their kind of current release process, and try to find the most kind of easy way to get to hook into their release process so that my tool could run alongside their tools up until the moment in which they felt comfortable with it and they were okay to adopt it. So first thing you can easily gain by using Kapitan, you don't even have to create like a configuration or manifest for it. It's just use it to at least solve the problem of context within Kubernetes, of how to anyway manage the environments in a way that you can run on multiple projects with multiple clusters without the developer being aware of that complexity. So what you can do is you can start creating classes that map the clusters you have installed Kubernetes on, and I basically create a small script to just generate that kind of initial setup for me. And then by using kind of this very quick template, this is like a Jinja template. I don't know if you've used it, like a Python templating was mainly for creating like text. This is very similar to, for instance, the Golang template approach that Helm uses now. But we use it in this case to generate like an output file that contains all the information we need to talk to our environments. Because by doing this, I can basically go from having instructions for release process where somebody says, oh, connect to the prod environment and run this command. I can go to a setup where I have scripts with no actual arguments to pass on, where I know that when whoever runs that script, whichever the setup is on their machine, they will be able to talk to the correct environment. In this case, I have Minikube. If you had a Kubernetes cluster on Azure or on GCP, you can wrap your script around that kind of complexity so that all they need to know is how to run these 3 commands and nothing more. You can then easily use the same kind of approach. This is more like to show the first presentation when you want to, I can show that you've done something. You can easily create like a documentation using the same approach. This time he creates like some Git kind of MD markdown files that allows you to show the exactly what kind of version, what project, what cluster, what namespace, all the information that might be relevant for people that usually come to you and say, what's deployed on this environment, or what's the current state of release on production or on staging. They're now able to go, by just going to the Git repository of this templating, to understand exactly how it's been set up. They can go and look into the manifests. They can see each single configuration that you have, because everything is accessible to them. Little by little, I basically, once I had this basically framework working, I was able to use this initial tooling to query Kubernetes to apply like small tests on Kubernetes. I kept on basically adding one component at a time. So in this case, this is like an example microservice where I basically define a class and I define where the microservice template is configured, and I just pass like basic information to this class. And as you can see here on the other side, I'm using a JSONette, which is much simpler than what we saw before, because in this case, given that I had like 15 microservices, I was able to define a common class that defines their behavior, and now it's much easier. Every time I want to add a new microservice, I just need to create like a little kind of leaf template like that. I define a class that allows me to point to that configuration, and now it becomes much easier. Every time adding a new microservice means adding these 2 files and changing a couple of names. The point is that every time I was adding a new component, I was using like a YAML a JSON kind of diff between what I had generated and what's actually deployed out there. And again, trying to aim for this setup where the diff between the two, the generated file and what's out there, is as little as possible. Because once I then send the merge request to my colleagues, they can see that my code is generating something that will basically cause no effect on production. So they are more likely to accept my change. And again, the point is to swap the deployment process rather than bringing improvement to the project at this point in time. So I don't know how I'm like with time, but yeah. So I just wanted to kind of share a little bit how if I succeeded or not. So the presentation was meant to be like 100 days as in days. I've actually been there for probably 50 days because I was on holiday and doing other things. So the good thing is that first of all we were able to I was able to quickly show a value in using Kapitan and to convince them that it was the right direction to go. Before using the templating that they had available, they were able to quickly advance in version, release this new version of the code, but they were afraid when those changes were affecting the whole kind of infrastructure. So for instance, moving to Istio or to other kind of mesh technology would have required us to think very carefully about our choice. Using Kapitan, because of this approach where when you compile, you see the compiled file together with the change that you made, allows people to be much more confident that a change that they do will actually have the impact that you require only on the environment where you enabled it. So allows us to cover basically all the Kubernetes manifest that we have. We moved from a page and a half kind of release process, very kind of ambiguous in the terms, to a 3-command release, and anyone within the company with the right access, even if they have never used any of this tool, are able to deploy without having any special setup. While, for instance, before you had to have a full Golang environment to be able to deploy to Kubernetes, which I found was very kind of difficult to work with. Prod and staging are being released using Kapitan. We have just today, I think it took me a little bit longer to finish this presentation because just today one of my colleagues was pushing changes to get Minikube enabled on his laptop, and he did it completely on his own, and I was super excited about the whole thing. And I've received a contribution to Kapitan from colleagues, and the most amazing thing is that although I'm the only person in my team at the moment, and we're building a team, I was able to go on holiday, and they basically carried on using it. So that was, for me, was the greatest achievement, because I knew that even if something broke while I was on holiday, because of this approach, they could fall back to whatever they had before. They didn't have to, and they actually had a very good kind of experience with it. So yes, I mean, this is the idea was exactly to show you this journey I went through, and to see if that inspires anybody to follow a similar approach, even with other kind of technology, but preferably with Kapitan. We have a blog giving you details on how to get started with it. There is also a Katacoda tutorial. Some of the team is here, so if you want to have a chat with us, just let us know. And most importantly, I have stickers all over the place. So if you see any of these stickers, it would be very, very good if you could spread the word about this software as much as you can. Thank you very much.